Start. In this section, we will cover other type of equations. The first one on polynomial, we will anticipate complex roots or complex solutions. Anticipate complex solution, even though we don't cover that. But for the easy one, we can just work it out. Okay, I'll start with the first one, polynomial type. Polynomial equations. We rely heavily on factoring. For example, number 6, 36x cubed minus 100x. Keep in mind, the first factoring that you need to try every time you have factoring in mind is greatest common factor. In this case, we have common factor 4x, I believe. So I take 4x out, I have 9x squared minus 25 left inside. Factor further, the guy inside the parentheses is difference of squares. And from there we see that x1 is 0. It's actually 4 times 4x equals to 0. Supposed to be 4x equals to 0. But you see if the coefficient, you can just ignore a coefficient. Okay, x2 is negative 5/3 and x3 equals to 5/3. Give me a second. That's for number 6.
Excuse me, teacher.
Yes.
You kind of explain how you got the fractions.
That's 3x plus 5 equals to 0. And then you solve for x. You subtract 5 divided by 3.
All right, I got you.
Okay. Okay, number 10. 27x cubed minus 343 equals to 0. We see that this is actually 3x to the power of 3, and this is, as I know, 7 cubed. So 0. Then I will factor by difference of cubes. That is 3x minus 7, 9x squared plus 21x plus 49 equals to 0. Now, I believe I mentioned before that when you do factoring by sum of cubes or difference of cubes, the second factor, the one with longer factor here, the factor with more terms, is most of the time is not factorable using standard way. So you will see that I will solve this by either a formula or completing the square. In this case, I will solve that by formula. Okay, so 3x minus 7 equals to 0, or 9x squared plus 21x plus 49 equals 0. This guy is x equals to 7/3. And the one here, I will use formula. Let me first compute the discriminant. discriminant is 21 squared minus 4 times 9 times 49. I wonder what's that. That's 7 times 3. That's minus 3 times 21 squared. That's negative 1,323. I prefer to do it this way so that it can make it easy for me later on. This is 21 squared. This is 7 times 3 times 7 squared. This guy here becomes this. Okay, and then I will get the discriminant is 21 squared minus 4 times 21 squared. So the discriminant is negative 3 times 21 squared. Now the square root of d will be square root of negative 3 times 21 squared. That is 21i square root of 3. So the other two solutions are, I think I should say x2, 3 instead. This is x1, x2, 3. Move it a bit away. Will be negative b plus minus square root of d, which is 21i square root of 3 over 2 times 9. But I can factor 21 on the top. And then at the bottom, I have 2 times 9. Cancel the 21 with 9 by 3. So the final answer will be negative 7 plus minus 7i radical 3 over 6. I think I still need to give myself some space here. Oops, sorry. So, I continue here. So, x2 equals to negative 7 plus 7i radical 3 over 6. x3 equals to negative 7 minus 7i radical 3 over 6. As we expect, we should have 3 solutions. Yeah, because it's degree of 3. It's degree of 3, right? So we should have 3 solutions. Now, I think the factoring difference of cubes, even though it was something tough for you, maybe something we don't get used to in the past, but I think in this case it's actually quite easy to do. What you need to focus more on is how to factor this. I'm sorry, how to solve that. Now, in this case, I solve it by quadratic formula. And to simplify my computation, I do the discriminant first. Okay, I do the discriminant first. That's for number 10. Let's go on more on number, let's see. Number 12, just factoring again. Number 14, still factoring. Don't get me wrong. Number 14, for example, it is still factoring. X cubed plus 2x squared plus 3x plus 6 equals to 0. This is still factoring, but I think we will do the factorization by grouping. x squared times x plus 2 plus 3 times x plus 2. So x plus 2 times x squared plus 3 equals to 0. So x1 is negative 2, x squared equals to negative 3, x equals to plus minus square root of negative 3, which is plus minus square root of 3 times I. Therefore, my x2, x3 is radical 3i and negative radical 3i. That's for number 14. Number 20. Number 20, 36t to the 7. 36t to the 4th plus 29t squared minus 7 equals to 0. Okay, now this is still polynomial, but because of the pattern, this actually falls into the category of quadratic-like equation. Why? Because this guy here is the square of this. Now we will use the technique of quadratic-like equation. Quadratic-like equation is not a quadratic equation, but with some appropriate substitution, it becomes a quadratic equation. Okay, so like for example, in this case, if I say my u equals to t squared, then u squared will be t to the 4th. Right? Okay. Basically, the variable part of one term is the square of the variable part of the other term. So if this is my u, then this will be my u squared. Okay? So with that said, then I will do the following substitution. I will say let u equals to t squared. Therefore, u squared equals to t to the 4th. Now then, with that substitution, I get 36u squared plus 29u minus 7 equals to 0. I will solve for u first, and then later on, I bring it back to t's. I wonder if I can factor this. Try 9 and 4. Six and 6 will do. What am I doing? 36 and 1. 36u and u minus 7 plus 1 equals to 0. So u equals to 7 over 36, u equals to negative 1. Now then I substitute that back, t squared equals to 7 over 36, t squared equals to negative 1. So t is plus minus square root of 7 over 36. T equals to plus minus square root of -1, which is plus minus I. Now don't forget, I would like you to split it. Okay, so T1 is radical 7 over 6. T2 is negative radical 7 over 6. T3 is I. T4 is negative I.
Professor, does it matter if the because when you did the 36u minus 7, you didn't make the 7 negative. Does that matter since you're doing the plus and minus at the bottom, or it's not supposed to be a negative 7 over 36?
It's not supposed to, because 36u minus 7 equals to 0. When you add 7, it becomes positive on the other side.
Got it.
Right?
Got it. Yes.
And then let me continue. Now we will still use the quadratic-like equation in the later part. For example, let me just go ahead to number 22. Actually, you can do the same thing, but let me just go ahead to number 26. Number 26. 6 times x over x plus 1 squared plus 5 times x minus x over x plus 1 minus 6 equals to 0. Okay, of course, if you try to attack these questions head on, no way, there's no way to do that. But you notice that this variable here, the variable part of this term, is the square of this variable part, right? Do you notice that? So if I substitute that temporarily with u, then the equation suddenly becomes a quadratic equation. So now I get 6u squared plus 5u minus 6 equals to 0. Okay, and then we factor it. I think that's 3u plus 3. So u equals to 4 over 3. U equals to negative 3 over 2. Now then I put it back. Actually, for this one equation here, you can solve this very easy. I mean, if you look at that, if you look at this equation here, if x equals to 2, then x plus 1 equals to 3, right? So x equals to 2, is it right for this one? You see what I mean? When x equals to 2, then x plus 1 on the denominator will be equal to 3. But of course, that's not a proper way to solve it. But at least it's nice to know the answer without going through the work, right? But you still need to show the work, okay? How to solve that kind of equation. If you have a fraction equals to a fraction, one way to solve that is to do cross multiply. I wonder if you remember that. You get the product of this equals to the product of this. Okay? Or to be more precise, we say we multiply by the LCD, which is 3 times x plus 1. If we multiply by the LCD, we will get 3x equals to 2 times x plus 1. So x equals to 2 as we expected earlier. Now likewise, I will do the same down here. X over x plus 1 equals to negative 3 over 2 multiplied by the LCD. Move it a bit to the right. multiply by the LCD 2 times x plus 1, then it will be 2x equals to negative 3 times x plus 1. So 2x equals negative 3x minus 3. 5x equals negative 3. X equals negative 3 over 5. Okay. Now let me leave it here for a while so that you can copy that down if you are. But you see, so instead of solving for x directly, we solve for this expression first. Basically, we solve for this expression first before we hit the x. So we solve for that u first. Okay, once we get the u, then we solve for x. Okay. Let me go on. Let's say, which would you like me to do, number 28 or number 30? I think I do number 30. Okay, I do number 30. I will go back to number 28 in later point of view. Number 30. Yeah, because number 28 can also be seen as radical equation, just like number 30. Number 30 also radical equation. But for number 30 case, it is better to be seen as quadratic-like equation because t to the 2/3 is actually the square of t to the 1/3. Okay? T to the 2/3 is actually the square of t to the 1/3. So let u equals to t to the 1/3. Now when we square that, t to the 1/3 being square, then we multiply the exponent. I wonder if you remember that. We multiply the exponent. Okay, 1/3 times 2 will be 2/3. Okay, now therefore we will get this equation now. 9u squared plus 24u plus 16 equals 0. That's the equation now. The thing is, I think I will factor it. Okay, I see that this is, the base is 3u here and the base here is 4. The product is 12u, but if I double down, it matches there. You have to double down, double the product of the bases. If it match with the middle term, then it's perfect square. Okay, so in this case, it is a perfect square. 3u plus 4 being squared equals to 0, which means 3u plus 4 equals to 0, right? If something squared equals 0, then that thing must be 0. So 3u equals to negative 4, u equals to negative 4 over 3. But we are not done yet. We are not done yet. This u is t to the power of 1/3, which is cube root. It means cube root. Cube root of t is negative 4/3. Now, how to undo the cube root? We cube both sides. We cube both sides. So t equals to negative 64 over 27. Is it hard? I know this is quite new for us, right? Long time no see.
Yeah.
Yeah, it's hard. I'm not gonna lie.
So yeah, because we have a lot of things put together here. Notice that this question requires you to know first what kind of substitution you need. Second, you need to know how to factor, and especially you need to identify a perfect square. Okay. of course, then you need to know how to solve a linear equation, which not supposed to be counted anyway, right? I mean, we expect that you know that already. And then when you substitute back, that back to t, then you need to know how to solve for this, right? Okay, now to solve for this, you rewrite that into cube root first. So to solve for this, you need to know what it means. Then you realize, oh, to cancel cube root, we cube both sides. Okay, so now the thing is, when I ask you questions in my test, usually I ask this kind of question instead. Why? Because instead of asking you 5 different questions, one for each topic, I rather ask you one question that covers 5 topics at once. Do you notice that when you have a test, right? Sometimes you ask how many questions there, and you prefer less numbers of questions, right? Just like this. If I ask you, do you want 5 questions or 1 question in your quiz? Let's say I give you a quiz for 10 minutes, right? Do you want 5 questions or 1 question? Now, most of you will say 1 question, right? Okay. Now, if I do 1 question, but at the same time, I need to cover a lot of topics, then this is the question I ask, right? Why? It's 1 question, but at the same time, you need to know so much. And anytime you miss any part, you basically get stuck. That's why it is actually not a good idea in math. It is not a good idea to request the teacher to give less number of problems. That's actually not a good idea, unless you get an easy teacher. Okay, if you get an easy teacher, lazy teacher, you don't even need to ask. That teacher will make it like that. You see what I mean? Okay, but if you have an appropriate teacher who wants to prepare you for, in this case, your business calculus, then if you ask me to give you less number of problems, I will pick questions like this. Yeah, this question is called condensed, which means in this one question, you need to know a lot of parts. Okay. Yeah. So yes, this is considered, for me, this is considered a hard question. Why you need to know so much? Let's compare that to this question here. Let's compare that to this question here, number 10. Number 10 is actually not hard. This question is long. It's not hard. That question is long, okay? Even though it's long, but the procedure basically just little easy parts. Okay, so you need to do this, you need to do that, but when you look at the work, let's say when you see this, oh, that's difference of Q. So I did difference of Q. Oh, this is linear. Oh, I use formula for this. I mean, each steps is pretty clear. Okay, now the thing is what we have here, not really though. Like, so you should have that planning since the beginning of your work. Okay, but at the same time, don't get discouraged. Okay, practice makes perfect. Okay, practice makes perfect. If you don't need to practice to make yourself perfect, then what you do is something everybody else can do. Okay, and if I teach you something that you can do even without me teaching you, then my lecture is worthless. Okay, and what you think that you can be proud of is actually not a pride at all, because what's so proud about doing something everybody can do, right? No, that's not the reason you come back to school. The reason you come to school is that you want to learn something new, such that later on, I talk a lot about business calculus. Okay, so from business point of view, what you are doing right now is to cultivate yourself, invest in yourself, right? Okay, such that once you graduate, you can market your skill and get the appropriate pay. Okay. Let me give you some story time. Would you like some story time? To relax you a little bit. Nobody say yes.
Yes, sir.
Okay, let me share this with you. second. Not this, not this. Not this. This one. I did tell you that I'm Indonesian, right? This is Indonesian money. This is Indonesian money. Can you see this? The largest denomination of Indonesian money is 100,000. 100,000 rupiah. Okay, and then the smallest one, paper note, is 1,000 rupiah. Let's see if they have the list. Something that they can show you. Oh, this one. This one. Yeah, let me screenshot this. I actually have Indonesian money at hand, but there's no point for me to show it to you by Zoom. But if you were in my class and this is calculus for business class, I would have shown you this. In fact, in the past, I gave 5,000 Indonesian dollar to my students who got an A in my class. Now, the thing is, do you think this is a big money?
No.
No? Good that you feel it, right? Okay, let me show you the exchange. This is the exchange right now, the current exchange. Thomas, what's the point you show us this thing? What's the point of you showing us this thing? Well, to tell you that you may have a diploma that looks like this. And of course, everybody's so scared with this. Oh, it must be a lot of money. Until you realize with this current exchange, this money here is less than $10. This is less than $10. Your diploma may look like this. Your diploma may be something look like this. You may have a bachelor, you may have a master's, you may have a PhD, but nothing you can buy with that diploma. What for? You waste your time. You only have the pride, but eat that pride. You know what I mean by eat that pride? Pride can never put any food on your table. Never. So what's the point of you having a diploma like this? You rather have a $100, 100 US dollar. That's actually worth a lot more. In fact, this 100 US dollar is the money that you can bring to any part of the world and people will accept that. This 100,000 Indonesian dollar, come on, man. Only Indonesian will accept that. And you can only buy things, small things back in Indonesia. I hope I make my point. What you aim for is not only passing the class. What you aim for is actually not only transferring or just having a degree, but know what your degree can quote unquote buy. Okay? You know the saddest thing in Indonesia? Okay, no, I'm not talking shit about my country. Okay, no. I'm talking about don't make your diploma to be like this. Okay, the saddest thing in Indonesia is this. In the capital city, Jakarta, if you go park when you park, not like in LA, most of the time when you park, you don't need to pay. Like in our school, right? In our school, you go to our school, you pay the student fee, let's say how many, like $7 if we have that parking, right? Okay, and that's for the whole semester. Okay, now the thing is, in Indonesia, 10,000 Indonesian dollar is what you need to pay when you park for 1 hour in a mall. You see what I mean? Okay, now I saw somebody make a comment of that's the power of capitalism. Yeah, we have to agree. Yes, of course, there is weakness in capitalism. Okay, there's weakness in capitalism. But if you can, until you can come up with a better system, unfortunately, and a better system and work, okay? Not just better system in your mind. Opinion is cheap, right? I think this is better. I think that is better. But until you execute it, if you cannot execute it, that's only a dream, right? Okay, but capitalism is, however bad, of course, there's a plenty of negative side effect of capitalism, but still the positive outcomes of capitalism, it's still more than other system. And to tell you the truth, the reason you take business calculus because you want to learn how to actually benefit from capitalism, right? Okay, come on. Capitalism creates business, okay? And that's why you want to learn that. Now, coming back to this, I hope you remember this illustration for the rest of your life, that your diploma can be this kind of money. It seems to be very big numbers, but nothing you can buy with that, and it's not acceptable anywhere, except some places. And even in that place that accept that, you can only buy with 100 US dollars I mean 100,000 Indonesian dollar, you can buy at most 2 pieces of chicken. Like when you go to Popeyes or KFC, like in Indonesia, you can buy at most 2 pieces of chicken. That's the most you can get. I'm sorry, you know. While with $100 in United States and everywhere, that's more than 1 day's meal for 5 people, right? You see the difference? Okay, so stop telling me that you have what degree. Doesn't matter. Until you can fit your family with that degree, you are nothing yet. You are meaningless. Okay, now I'm saying this not to say that you are meaningless. No, I'm saying that you are now preparing yourself to be useful, right? Okay, so don't aim for your diploma only, but aim for how you use that. Okay, aim for how you use that. Okay, capitalism at the same time enable people like Mark Zuckerberg, people like Bill Gates, those who actually never have a degree, but end up providing so much money to big universities, you know, okay? And only capitalism can make it happen. You know, it won't happen in other place. Okay, let's come back to our class, of course. Okay, I hope that's worth it, that me spending 10 minutes there telling you about the Indonesian money is worth it. I don't want you to be in that situation. Okay. Some people once asked me this question: Thomas, you did your PhD at USC, right? And yeah, USC is a good school, don't get me wrong. Okay, USC is a good school. Okay, but why don't you just finish it? Why don't you just finish it? I say, why do I have to finish it? I already get the job. Right? My job is good. My job is good. But don't you think having a PhD will be great? Yeah, of course it will be great. But will that turn into money? Okay? I mean, the purpose of I went back to school so to improve myself, but at one point, and I need to start making money, start to put our terminologies. I put food on the table, right? I have my parents to support. I have my family to support, right? Okay, and of course, in America, it's not cheap. And taking care of Indonesian parents, my parents in Indonesia, and the health care there is very expensive. Okay, basically, if you get sick, for a lot of people, once they get sick, they can't even go see a doctor. You know, okay. By the way, and we have universal healthcare system back there, but it's still expensive. It's still expensive. For you to go see a doctor, you need to wait for months. Anyway, what I want to show you earlier is this. Are you looking at my browser? Yeah. Why don't you finish your PhD, Thomas? Okay, here's the reason. How much do you think a PhD makes? Transparent California. You see the website here? This is actually a California website. I mean, by California government. Type my name. You will see my salary. Before I show you, can you guess how much I make per year? Anybody? Nobody say anything. You can't even guess, or you just don't care.
Like $80,000 or
80,000. Do you think $80,000 is a big money?
to live in LA, it's decent.
Okay, that's yeah, I agree with you. 80,000 is decent. It's above average for, it's how to say it, with a family of two, like with two children, 80,000 is a bit more than what's needed. I think in LA for you to live like on average, right, around 60,000. This is how much I make. What do you think? When somebody say, holy shit. Yeah, somebody asked, is it before or after tax? It's before tax. After tax, no. You don't. I understand. Don't worry. I didn't take it as an insult. Don't worry. I don't take it as an insult. No, it's because of this. Why most students, when I ask them to guess my pay, they actually, not only most, all of them actually gave me the estimate that is actually lower than supposed to be. Two reasons. First one, and I think that's the most important one, is that a lot of you underestimate education. You don't take education as something worth it. I'm not saying expensive. I'm saying about worth it. If you don't see education as something worth it, then once you put money value into that, your education, then you tend to see it in the lower value. Okay? And to be honest with you, you need to be grateful with America that they still provide you financial aid. Now, I'm not talking about Trump's presidency. No, financial aid has been there since many years ago. 20 years ago, it's already there. When I did my master's, I get financial aid. Okay, so no, it's not about Trump. Okay, it's been there. This country is built so well, in my opinion. Of course, there are weaknesses, right? But it's built so well such that immigrants like me can come from a poor country in Indonesia, and I come from very poor family in poor country in Indonesia. Can you imagine that? Okay, and now I can earn this much money. Okay, only capitalism can do it. Okay, of course, not every capitalism though. Okay, our democracy is also very well built. Okay, there are still many things we can do better. Okay, there are still many things we can do better, but at least, in my opinion, you see my pay here, right? Okay. We are actually still one of the best countries to live in the world. Okay, but again, we still have a lot of homework to do better, and that's why I share this with you, so that once you have your bachelor, once you get your degree, once you get your job, either in private institution or public institution, then you can look for opportunities to make our society an even better place. Okay, now second, about tax. My tax actually change depends on IRS, depends on the administration, but I can tell you I get approximately half of this. So the regular pay you see here, okay, what I get at the end of the year after tax is approximately half of this. It's approximately half of this. Yeah, let's say around 90,000. Yeah, let's say around 90,000. Yeah, even my tax bracket already around 30%. Is it 30% or 28%? Not sure, or 25%. I think it's 25%, but then together with the state tax and then property tax and this tax, that tax, like if you're alive, you pay tax. If you're dead, you still pay tax. It's like nothing sure but death and tax in America, right? Okay, now take a look on my other pay and this benefit. You see this benefit? This is the benefit I get for my healthcare. That's for my healthcare. That's how much they pay for my healthcare. Of course, if I myself, I will not pay that much, right? I don't want to spend money for that. Okay, but the district actually pay me for that. Okay, now the thing is, besides working at West LA College, East LA College, I also work at Santa Monica. So in 2008, for example, in 2008, you see, this is my pay at Santa Monica, 2008. That's not what it is supposed to be. The notation is not correct. Let's say, for example, 2007. 2007, that's at LACCD, and then 2007 at Santa Monica. So close to 200,000. Yeah, close to 200. If I include the benefit and other pay, then it would be 200,000. Now, do you want to be like me? Yes, education is very worth it, and try to benefit as much as you can from your school. And I really hope that what I share with you here, how I teach you here, also bring you up to the realization that, you know what, I as a teacher try to provide you an education that worth my pay, okay, and show you that, you know what, as long as you study it right, learn it right, don't close the door for you, saying that, you know what, I'm just West LA College graduate. No, I have seen my former students from West LA College doing making very, very good money, okay? Okay, and they make very, very good money regardless who were in the administration. And that's how I want to train you, okay? Such that your welfare, your, do I use the word right? The wellness, I should say, your wellness, not welfare, your wellness, not depending on who is the president, okay? In other words, in this November, whoever get elected, hopefully you will be fine with the skill that you have. That's what I want, okay? That's what I want. So whoever the president, you will be doing fine. You can make the money, provide the food for your family, and still your happiness is not being discounted by whoever in the administration. Okay, now let's continue with this number 32. In fact, at USC, when I did my PhD at USC, I also taught business school. I think I shared that with you before. And even though I taught the math part from the students through our conversations, sometimes I overheard, and sometimes actually I actually talk with them also. They share with me that if the president is from Democrats, this is what they will do. This is the type of stocks they will buy. If the president is Republican, then this is the type of stocks they will buy. In other words, they already have plans, even at their bachelor degree, they already thought to have plans on how to invest, what kind of industry or what kind of field will flourish for whoever the president becomes, like, from which party the president is. Okay, yes, and then when I remember that time, it's just like, oh wow, no wonder they say these business students from USC are doing well, because they are trained to perform well whoever in the administration. And it's actually not only about being who is the president, it's just like under what situation. In each situation, they know how to survive. And I hope you can actually also learn from that. Number 32, this is basically factoring again. The question is, which I forgot to write, is find the y and x intercept. The y intercept, if we need to, eventually we will need to graph this polynomial. But for now, let's find the y intercept. Y intercept is when x equals to 0. Okay, so when x equals to 0, I get y equals to 0 minus 0 plus 0, that's 0. So the y-intercept is 0, 0. That's easy. How about the x-intercept? The x-intercept will be, we set the y equals to 0. We set the y equals to 0. And then you solve for x. What do you think we will need to do first? What do you think we need to do first? Oops, sorry. Factor x squared, that's right. So 0 equals to factor the x squared, I get 2x squared minus 15x plus 18. So I factor this is 2x and x. I need minus 15. So minus 6 minus 3. So x squared equals to 0, which means x12 equals to 0. x3 is 3 halves. x4 is 6. There are 4 solutions supposed to be because it's degree of 4. So x1, x2 are both 0, x3 is 3 halves, and x4 is 6. Now, the next type, the third one, radical equation. Radical equation. Idea. Square root of blah equals to blah. We can get rid of the square root by squaring both sides. Now, when I say squaring both sides, we are not squaring term by term, but we are squaring the left-hand side and the right-hand side. Okay, such that we get blah equals to blah squared. Now, the thing is, some warning, this procedure may give extraneous solution. In other words, you may get a solution that does not satisfy the original equation. Okay, so we need to check each solution, check each proposed solution against the original equation. Okay, now, let's say number 36. Number 36, 7 square root of x minus 4 equals to 0. What I will do is I will isolate the square root of x. Basically, I isolate the radical. Oops. I will square both sides. This is what I get. Now then, I will check this solution against the original equation. So 7 times square root of 16 over 49 minus 4 is equals to 0. Yeah, we put question mark above the equal sign when we check that. So the solution is x equals to 16 over 49. Not plus minus. We do plus minus only when we apply square root property. When we apply square root to both sides, but not when we apply square both sides. Okay, not when we apply square both sides. Now, I'm about to give you some exception where under what situation you don't need to check. Under what situation you don't need to check. If your pound here, if the pound here, the other side here, if you want to check, still okay. You can always check. I mean, checking is not wrong. It's just like under what situation the checking will be not necessary. Okay, you don't need to, but you still need to check if the pound that you see there, the pound that you saw earlier, the other side of the radical, if the pound is greater equals to 0. It's a constant. If a constant, if that is a constant, is a constant greater or equal to 0. Okay, like in this case here, this guy is already positive constant, right? Then whatever the result, that will be true. You don't need to check. You still can check, okay, but you don't need to. Now let's see number 38. Oh, number 38. Yeah, number 38. And more space. Radical 5 minus x minus 3 equals 0. Radical 5 minus x minus 3 equals 0. Square root of 5 minus x equals to 3. Now, so you see square root of something is positive. Then when I square both sides, I don't need to check later on. 5 minus 9 equals to x. X is -4. You can check x equals to -4 into this equation and you will find that to be true. Okay. Now coming back here, this is actually for nth root. Doesn't have to be only square root. Nth root still the same, but when the index is odd, then you don't need to check. For example, number 40. It has something to do with the domain of the equation. Cube root of 3x plus 1 minus 5 equals to 0. So I move the 5 to the other side. Now to undo the cube root, I cube both sides. Take it to the power of 3. Okay, so 3x plus 1 is 1.5. 3x is 1.4. X is 1.4 over 3. Okay, so for odd index, you don't need to check either. Regardless, on the right-hand side is what? Regardless what you have on the right-hand side. Doesn't matter. Doesn't matter. Positive, negative, constant with variables, doesn't matter. Because cube root has a certain property that we will see in chapter 2, that it is actually one-to-one function, while the domain is all real numbers. But we will see that later. Okay, only square root you need to check, or fourth root. Okay, even index, then you need to check. Okay, now let's see number 42. Number 42, write it here. X plus square root of 31 minus 9x equals to 5. I will isolate the radical. Let me move the negative a bit to the left so that I have enough space. Square root of 31 minus 9x equals to 5 minus x. Now I will square both sides. But notice when I square both sides, the right-hand side becomes 5 minus x, quantity squared. Moreover, notice that the right-hand side, the other side of the radical, notice that the other side of the radical is not a positive constant. It's not even a constant, it has variables. So we know once we square both sides and solve this, I need to check whatever the final answer I have later on. Okay, make sure you check because the other side is not positive constant. This is 25 minus 10x plus x squared. That will be, let me shift that further to the left, 0 equals to x squared minus x minus 6. So I get x minus 3, x plus 2, or x equals to 3, x equals to -2. But we are not done yet. Remember earlier I say, if you square both sides, of an equation, then you may have extraneous solution. Therefore, you need to check whatever solution you have. The only exception is when the other side, this side here, if that happens to be a positive constant, which is not the case we have here. Like this case, positive constant. Okay, but if you have variable or if it's negative, then you need to check. Okay, so I will check against the original equation. When x equals to 3, so I get 3 plus square root of 31 minus 9 times 3. Is it equals to 5? 3 plus square root of 31 minus 27, is it equals to 5? 31 minus 7 is 4, square root of 4 is 2. So 5 equals 5. That's a check. It means x equals 3 is a solution. But I still need to check when x equals to negative 2. Negative 2 square root of 31 minus 9 times negative 2. Is it equals to 5? So negative 2 plus square root of 49. Is it equals to 5? Negative 2 plus 7. Is it equals to 5? That's true. That's equals to 5. So for this question, we have two solutions. So x equals to negative 2, x equals to 3. Now what happens if we have now what happens if we have two radicals? What happens if we have two radicals, like number 46, for example? And we will isolate one of the radical, square both sides, and then isolate the other radical again. So square root number 46, square root of x plus square root of x minus 20 equals to 10. Isolate one of the radical. Square both sides. X minus 20 equals to 100 minus 20 radical x plus x. The x cancels, right? The x cancels. Subtract by 10. Divided by negative 20. I get 3 over 2 equals to square root of x. Right? Okay, and then I square both sides. That's 9 over 4, right? Equals to x. Now the thing is, we don't need to check this part, but I still need to check this part, especially, right? Because the other side has radical. Okay? So if you wonder, should I check this or not, then check that anyway. Okay, never wrong, never wrong. So I will check this. Square root of 9 over 4 plus square root of 9 over 4 minus 20, is it equals to 10? This is 3 over 2. But the problem is, you see here, this is this is a negative number. This is negative number, less than 0. So this will be not a real number, plus not a real number. So in other words, so 9 over 4 is not a solution. It doesn't check. Finally, then we say this equation has no solution. No real solutions. I prefer to say no solutions, but I will accept you when you say no real solutions. But I believe our textbook will say no solution in this case. I'm still checking if I make a mistake. But yeah, I found my mistake. I make my mistake here. It should be 100 here. So I make mistake. Hold on. I make mistake. So this should be negative 120 divided by 20. That will be positive 6. This should be positive 6. My bad. So this is 6. This becomes 36. Okay, so I checked a wrong number. So I should check 36. My bad. Missing that 10 make me see if I try to do things too fast. 36 minus 20. So this is 6 plus square root of 16 is 4. Oh, that's true, huh? So 10 equals to 10. That's a check. So x equals to 36. Yeah, good thing I checked that in. Otherwise. Now, for this type of question, you need to practice at home, though. You really need to practice at home. A lot. You need to practice a lot at home. Why? Because the square root actually scare us. I mean, me too. Me too, when I learned that long time ago. Every time I see that, it's like, huh? Do I have to do this? Is there any way to cheat this? And it always turns out to be... My teacher always said this to me. When I learned this first time, like myself, my teacher always said this to me. I'm your teacher. Imagine my teacher is Indonesian. Okay, I have him, her in Indonesia, and this teacher say this. This teacher say this. If I am your teacher, just like Kung Fu teacher, I will teach you everything I know to make you good in Kung Fu. I will teach you everything I know in math to make you good in math. Okay, so if you keep on thinking, Thomas, if you can keep on thinking there's a secret method to solve the problem I gave you, then you basically, how she say? It's just like, she said that she didn't hide any technique, a cheating method that she didn't taught us, you know. But at the same time, she said that just follow the procedure. Okay, just follow the procedure. In between, you may see some hard algebra, complicated algebra, but it's doable. Okay, so I know it will take some time. Okay, hang in there, right? Just do it the way Thomas teach you, and be patient with yourself. Okay, I will square both sides here, so I will get 4 times x plus, maybe I write it down so that you see what I did there. So this is something squared. This is something squared. 2 square root of x plus 1. This is equals to 1 plus square root of 2x plus 3. Now then, when you square, this becomes 4 times x plus 1. This becomes 1 plus 2 square root of 2x plus 3 plus 2x plus 3. simplify each side. This is 2x plus 4 plus 2 square root of 2x plus 3. Now you see the plus 4 cancels. I subtract by 2x, I get 2x equals to square root of, 2 times 2 square root of 2x plus 3 divided by 2. Now I square both sides again. Set one side equals to 0, and then factor. So also from here you see expanding a plus b being squared and expanding a minus b being squared fast is kind of necessary. Okay, it would be nice if you can do it fast. Okay. If not, then then you end up it will slow you down. It will slow you down. X minus 3, x plus 1. So x equals to 3, x equals to -1. Unfortunately, we are not done yet. We are not done yet. We need to check. When x equals to 3, 2 square root of 3 plus 1 minus square root of 2 times 3 plus 3 is it equals to 1. 2 times 2 minus 3 is it equals to 1. That's 4 minus 3, that's equals to 1. Let's check. How about when x equals to 2? I'm sorry, when x equals to -1. When x equals to -1, the other solution, right? The other solution. So this is x equals to 3, x equals to -1. So 2 square root of -1 plus 1 minus square root of 2 times -1 plus 3 is it equals to 1. This is 2 times 0 minus 1 is it equals to 1. But this is -1. So it's not equal to 1. Doesn't check. So then we conclude, summarize, so x equals to 3 only. Okay, let me go on. That's not for number 48. How about the one we have here? Number 50 is pretty much the same. How about number 52? X plus 3 to the power of 3/2 equals to 8. Now, to the power of 3/2 means the cube of square root of x plus 3. So the exponent, the numerator of the exponent will be the exponent. The denominator of the exponent becomes the index. Okay, now that's equals to 8. Now to undo a cube, we do cube root. Cube root of 8, which is 2. And then I will square both sides. And because the other side is positive constant, then I don't need to check. X equals to 1. Number 58. Dude, I was thinking I can finish 1.6 today. It turns out that I can't. Okay, number 56, I will do it partially. I will not do all of them. Number 56, just I will do it partially only. X squared minus x minus 22 to the power of 3 halves equals to 27. That is the cube of square root of x squared minus x minus 22 equals to 27. So you see this is actually very similar to what we have there. Okay, very similar to what we have here. Blah to the power of 3 halves. Right? So I apply cube root both sides. That's equal to 3. And because it's already positive number on the right hand side, I will square without the need of checking later on. So x squared minus x minus 22 equals to 9. So x squared minus x minus 31 equals to 0. I'll go on from here. I don't think that's factorable. I don't even want to do completing the square. Then let me do formula. So the discriminant will be b squared minus 4ac. That's 1 plus 123. That's 124. The discriminant is, the square root is 124, I think, is 4 times 31. Oh, no. Yeah, that's 31. 4 times 31. Oh, I added wrong. My bad. My bad. What happened with me? I kind of like rushing. I make mistake here. It should be 124 here. This is 124. But this is 25 times 5, so 5 radical 5. So the solutions are negative b plus minus 5 radical 5 over 2 times 1. X1 is 1 plus 5 radical 5 over 2. X2 equals to 1 minus 5 radical 5 over. That's number 56. Number 58. My main problems, the most important problem I want to do from this section. Now, the one in number 58, this is considered difficult because you really need to be able to see the factoring first. Let's see. 4 and 6, the common factor is 2, right? X squared and x, the common factor is x. Are you with me so far? Now then, x minus 1 to the power of 1/3, x minus 1 to the power of 4/3. What's the common factor? Use the lower exponent. Use the lower exponent. X minus 1 to the power of 1/3. Now then, if I pull those out, what's left inside? 4, you pull 2 out, you have 2 left. X squared, you pull x out, you have x left. Okay, x minus 1 to the power of 1/3 out, you have nothing left for the first term. Plus 3 times, if you pull 1/3 out, you get x minus 1 to the power of 3/3 here. okay, which is equal to 1. So if I go on, this is 2x times x minus 1 to the power of 1/3 times 2x plus 3x minus 3 equals 0. By the way, blah to the power of 3/3, that's just blah to the 1, right? Which is blah. Don't forget that. So 2x, x minus 1 to the power of 1/3, 5x minus 3, that equals to 0. So either x equals to 0, x minus 1 to the 1/3 equals to 0, or 5x minus 3 equals to 0. Now x equals 0 is done. To the power of 1/3. Take it to the power of 3 to cancel the 1/3. So x2 equals to 1. And this one here, x3 equals to 3/5. Now I will stop here, but for the later part, I think you can do up to number 66. Yeah, you can do up to number 66. Suggested homework for 1.6a, all on this page is page up to number 67. Okay, the technique here, I believe I mentioned that last time with you, multiply by the LCD. Get rid of the denominator by multiplying by the LCD. Okay, I'm 3 minutes over time. I guess that's where I will stop.